Hi, today we will discuss about the project 3, identity server management. In this project, we have implemented strict consistency. Here is the architecture of our project. So this Axis works as a master server, and it is acting like a DNS server. Whenever client connects, it sends request to the master server, and the communication between client and the master server goes from the client communication protocol. And uh, once master server is started, it will starting all the nodes, and by using Bullies algorithm, it will elect a coordinator node. And after client connects to with master server, it will pass the port number of the coordinator, and client connects with the coordinator with identity.proto buff. And to communicate between the servers, between the server nodes, server communication.proto buff is used. So let's walk through with the master server code. So master server is started on the given port. It starts the Redis server on the backend. It also creates the task scheduler to save the data in every 5 minutes. Then it has shutdown hook, which ensures data is saved before shutdown and kill all the cluster nodes. Um, and then it destroys the Redis server. It creates cluster of servers, and starts each server node in different thread. Each of the cluster nodes started from 50511 port onwards. After after starting the nodes, it initiates the election, and we can easily add the new cluster node and remove the node from the cluster. Whenever coordinator node dies, it starts the re-election, and if the child node goes down, it just simply removes it from the cluster. So here we have started the server, and uh, all we have given maximum nodes 4. Then it will start these 4 nodes from 50511 port, and after that it elects the server coordinator, and we have a task scheduler, which is doing the health check of the coordinator node in every 5 or 10 minutes. So now our client is connected. So if we want to add a new node in the cluster, we just need to do add node. Now server 4 is started. Uh, and if we remove the coordinator node, then our new coordinator will be elected. So here it's shutting down ID 3, and after that the node 4, it will elect the new coordinator, and now node 4 was the highest node present in the cluster. So so node 4 will become at the coordinator node.
All right, hello, I'm Brayden Thompson, and I'll go over the coordinator node and other functionality. So let me spin up the server here and get a client going. I'll wait for it to fully start up. Okay, cool. And let me start the client. Cool. So we talked about this a bit in the in the README, but all the communications between the client and the coordinator server. So if we look at the identity protobuf file, we've got two main messages that are being passed back and forth: a write request and a write response, and a read request and a read response. So the client is sending a write request when it wants to make a write, and it'll have one of these fields populated, and it'll send the whole write request over to the coordinator. So we can do, and we also have the read request as well, which includes help and stuff like that, and it has a lot less fields that it needs to fill out. And there's the corresponding response, and those are the two main methods that are getting implemented. So when we type in help, we get the help we see in the server received read request, and we can do create video test I pass and create a new user, and you can see new user created, and you can see what the server's doing a bit here. So it receives the write request, it goes to the coordinator node, recognizes that's the coordinator, and it passes it to its children. And then they write it, it gets a response, passes it back up to the coordinator, which goes back to the client. And then the client receives this response from that. So we can show where that's going in the code. So the client calls one of these functions that makes a new either read request or write request, fills up the appropriate fields, sends it off to the coordinator. Coordinator gets it in this, which has the implementations of the two methods. So we have the write request method. It checks if it's the coordinator, places a lock on checks if there's a lock currently on that entry. It adds a lock, sends the write to all the children, and then removes the lock. And then down here, we can see where the writes get propagated. Here, we just get the list of servers, send it out to them, and then it sends it to the child node's version of this class and implementation of these methods, and then it actually commits into the Redis database. And that's, I think, pretty much, oh yeah, so it has the lock on it. So in the testing suite, you have it. So if you multi-thread send, two write requests at the same time, one of them will block whichever one gets there second. And while that write is happening, no reads can take place. So the read request also blocks. It's also got the check down here. So this also checks if there's currently a block on that current entry that it's requesting. Do you know if there's anything else I need to cover? I think.
Automated test.
Oh, yes. True. So yeah, let me run I remember nope. Okay, I can't remember that's to close. Okay, let me open up a new, yes. Okay, so while we have these servers spun up, we can do make test, and this will run the tests, a couple test cases, mainly just checking if the write lock is working and the read lock is working. So while that executes, we can go over here, and it should, in a couple seconds, start getting the logs from the test calls. There we go. And waits a couple seconds, make sure stuff's working all right. Cool. You can see up here, this is two writes happening at the same time. One of them got there first, and it blocked the second one until it cleared up. Yeah, so removing lock and modify test, and then the second modify test that was waiting can now go through and execute, and it doesn't actually do anything because the name changed because I'm using the modify function to test it, but in principle it works. It blocks as it should, and yeah, I think that's about it.
Yeah, so whenever our coordinators node killed, then client needs to connect again. And there is one limitation in our project, like we were not able to implement Docker image thing. We tried, but it didn't work out, and we don't know how to do that.
Yeah, you're not experienced with Docker too much. All right, cool. Anything else? I guess I'll stop the recording.
Yeah, we can.